Hello, class. This is Mr. Parsons here. Just want to take a few minutes to talk to you about transformations of linear functions. All right, so when we're looking at a linear function graphically, um, this function here is your parent function. This is the basic function, and your parent function usually has a slope of 1, because if you do your rise over run, you get a slope of positive 1. It crosses your origin, so the y-intercept is 0. And so if you write in the slope-intercept form, because you got a slope of 1 and your y-intercept is 0, it'll be y equals x. So that's called your parent function. Now this parent function can be moved or shifted, or what we call transformed, along your x and y axis. And when we do that, we call that a transformation. All right. And so you can either move it along your y-axis, which is vertically, or you can move this function along your x-axis, which is horizontally. We're going to first talk about moving it along your y-axis, which is a vertical shift. All right. And so the notation is f of x, which is your parent function. And if we do f of x plus a number, it's going to move up. If you do f of x minus a number, it's going to move down your y-axis. And so we look at numbers 1 and 2, we want to describe the transformation along our y-axis. So we got f of x plus 6. This is the parent function. And if we move, this is g of x right here, right? So we look like we're moving up 6 units. So we shift 6 units up from your parent function. If I look at number 2, h of x, this is h of x. Look at the relationship between h of x and our parent function. We move down 5 units. So f of x minus 5 represents a downward shift 5 units from your parent function. All right. So Louise graph g of x equals f of x plus, minus 4. Let's look at this graph on the right. So we minus a number, all right, vertical movement, that means it's going to move down 4 units. So this is the parent function. We move 4 units down. This will be our g of x. And what does that mean? We shift 4 units down from our parent function. Cora graphed the second line. So this is the second line, h. All right. Fill in the blank. So if this is my parent function, I move up 4 units. So instead of it being f of x minus 4, it's going to be f of x plus 4. How does the slopes and y-intercepts compare to the parent function? As you recall, the slope of the parent function is 1. If we look at the slopes for h and for g, they still have the same slope of 1. Okay? But since we shift along our y-axis, then our y-intercept change, because think about it, your y-intercept is where the graph crosses the y-axis. So it's going to change, your y-intercept is going to change according to how many units you shift either up or down your y-axis, but the slope is going to stay the same. Now look at 6. So f of x equals x, it's your parent function. Sophia is going to have f of x minus 2. Describe the slope of the y-intercept. Well, we said in number 5, the slope stay the same. So the slope will be the same. However, since we shifted 2 units down, you're going to cross your y-axis at -2. So your y-intercept is going to be -2. So your slope is going to be 1, and your y-intercept is going to be -2. Now, let's talk about a horizontal movement. Look at the notation here, f of x minus a number. So that whole expression is in parentheses. If we go back, just f of x, that x is in parentheses, not the whole expression. So that we got to make sure that we pay attention to the notation here so we can differentiate between the vertical movement and the horizontal movement. All right, so this indicates a horizontal shift. Now look at this here. We got to pay attention to this as well. So if I got f of x plus a number, that whole expression is in parentheses. If it's f of x plus a number, it's going to shift to the left that many units. If I got f of x minus a number, the whole expression in parentheses, is going to move to the right that many units. So let's look at number 7, f of x minus 1, that whole expression is in parentheses. So according to our general statement, we're going to move to the right. We're going to move to the right 1 unit from the parent function. Look at number 8, f of x plus 7. The whole expression is in parentheses. So when I add that horizontally, I move it to the left, and I'm going to move to the left 7 units. So if I look at this graph and I want to graph 7 and 8, since I move 1 unit to the right, I'm going to cross my x-axis at 1, and since I move 7 units to the left, I'm going to cross my x-axis at -7. So this represents m of x. This represents r of x. All right. If I look at number 10, Camilla graph f of x minus 5. So the whole expression is in parentheses. This indicates horizontal movement, and this is going to be moved to the right 5 units from your parent function. So since this is my parent function and I move 5 units to the right, this is going to be g of x. And what it means, it's going to be 5 units to the right. All right. I graph the second line. So this is the second line, h of x. We want to represent what it means. So it moves 5 units to the left. If it's 5 units to the left, horizontally, f of x plus 5. How does the slopes and x-intercepts change? So let's take a look at this. This is similar to our vertical movement. So if we look at the slope, similar to the vertical movement, you're still going to have the same slope, but your x-intercept is going to change. That makes sense because if you're moving along your x-axis, your x-intercept will change. All right, and it's going to change according to how many units you shift either to the left or right along your x-axis. So same slope, different x-intercept. So let's look at number 13. All right, and this is our parent function. We want to write the function of g of x. So this moves to the left 3 units. All right, so we move to the left. We're going to add. So f of x plus 3, that whole expression, x plus 3 is in parentheses. And number 14 says Julia will graph f of x, which is your parent function, and a of x, which is f of x minus 9. How does the slope compare? Well, as we stated previously, the slope is going to stay the same. Since your parent function has a slope of 1, this will have a slope of 1. How will the x-intercepts compare? Well, since I move 9 units to the right, because that's what it means, all right, then my x-intercept is going to be 9. All right, so when we're talking about here with transformations of linear functions, we're talking about the movement or the shifting of our parent function vertically along the y-axis. So that's saying f of x, just x, is in parentheses by itself. So if I do f of x plus a number, I'm shifting up. If I do f of x minus a number, I'm shifting down. Horizontally, f of x plus a number in parentheses. So the whole expression is in parentheses. I'll move it to the left that many units. And if I got f of x minus a number, the whole expression is in parentheses, I'll move it to the right that many units. And so the slope will stay the same, but if you're moving vertically, your y-intercept will change. And the slope will stay the same, but if you move horizontally, your x-intercept will change. So I hope this helps with our understanding of transformation of linear functions.